Our topic today is the volume of prisms and cylinders. Now, volume is in many ways closely related to area, except we're going in 3 dimensions instead of 2. When we talk about prisms, remember we're talking about a shape of some kind. It could be an irregular shape, but often it's a triangle, square, rectangle, octagon, or something like that. And an identical shape that's connected with lines. All of the corners or vertices are connected. So, for example, this is a prism. It's a rectangular prism. Rectangle, 2 rectangles that are connected. Okay? This is what is called a right prism. And you get a right prism when the base and the top are connected with lines that run at right angles to the base. Okay? So this is a right angle right here. That connection, that tells me it's a right angle. When I have something that doesn't, let's say we have a triangle here and a triangle here, and they're connected with diagonal lines, that's called an oblique prism. That's O-B-L-I-Q-U-E, an oblique prism. And when we have a prism that has a round top and a round bottom, it's not really a prism, but it's just like a prism, but instead we call it what? We call it a cylinder. Now when we're trying to figure out the volumes of these figures, the right prism is a nice easy one for us. For prisms, though, the basic principle is the area of the base times the height. So the area of the base volume is equal to the area, we use a capital A because it's the area of the base, times the height. In this case, we have a rectangle that's the base, length times breadth of the rectangle, so in this case, it would be length times breadth times height. So, for example, if we knew that this was 2, and this was 3, and this is 4, clearly not drawn to scale, then all we would have to do is say 2 times 3 times 4, which is equal to 24, and if they were in meters, then we would have meters cubed, or cubic meters. We're going to come back to the oblique prism. Oh, we'll do the oblique prism now. Oblique prism, same idea. We need the area of the base times the height. Okay? Area of the base times the height. Now what you have to keep in mind when we're talking about the height is not the length of that slanted line, or in this case going that way, not the slanted line, but the actual height. That's vertical height. It's like the height of a triangle. It's a right angle from the base, just like the right angle from the base over here. So our volume is equal to the area times the height still. Okay? So if we were to say, for example, that this was a square oblique prism, and we knew that all these sides were the same, and they were 3 centimeters, and that the height was 5, how do we get the area of the base? Well, in this case, it would be 3 times 3, because it's a square. So it would give me 3 times the height, which gives me 5. 3 times 3 is 9 times 5 is 45 centimeters cubed. Okay? Now the cylinders, on the other hand, still the same idea. Remember, still the same idea. Volume is equal to the area of the base times the height. But because it's a cylinder, we know what the formula for the area of the base is. So the formula for the area of the base, because the circle is pi r squared, so we have pi r squared h. So if we took this cylinder as an example, we made the radius 2, and we used millimeters this time, and we made the height 6 millimeters. And then we could say pi times the radius, which is 2, squared, times the height, which is 6. 2 squared is 4, times 6 is 24, times pi. That is my exact answer. If you wanted something to 2 decimal places, you could put it in your calculator, and you get something a little more than 72. If you put it in your calculator, you'd get that, and you could work it out to 2 decimal places. Now, what makes these a little bit more interesting occasionally, of course, is that not always are they quite this exact or quite this simple. Occasionally we get one other kind of form of figure, and that is something that is a composite figure. So let's say, for example, that we had a cylinder sitting on top of a rectangular prism, and that rectangular prism looks something like this. And then all we would have to do, let's say that we found out that this height was 3, this height was also 3, and we'll make it easy and say that the radius is also 3, which makes, if that radius is 3, then this length along here is 6, which you should have been able to figure out, and this is also 6, although I should have drawn that circle coming right out to the edge if it were that sort of a figure. All we have to do for this, and I'm going to let you do this on your own, is I would calculate the area of the cylinder. You've just gotten that formula. You have the height, you have the radius, you can figure that out, and then you add it to the area of this square, in this case square prism 6 by 6 by 3, and you can do that. Have confidence in you, and that is the volume of prisms and cylinders.